Let's continue with our second video of science for this week. We are on this page, Underground Water, page 40. Let's begin reading. God designed the water cycle because fresh water is very important for maintaining life on Earth. And one important aspect of the water cycle, which many people are not even aware of, is groundwater. 97% of the water on Earth is in the oceans. This water is too salty for human use. This water, the remaining 3% is fresh water, but 3/4 of that water is permanently frozen in the glaciers and polar ice caps. About 22% of fresh water is underground, and less than 1% of fresh water is available in lakes, rivers, and other surface water. This makes groundwater a vital source of fresh water. So let's draw a picture of that. If this rectangle represents all the water on the Earth, all but 3% of it, probably about that big, is salt. So this is fresh, and all this is salt water. I don't know if you've ever tried to drink salt water. If you've ever been to the beach and gotten water, salt water, ocean water in your mouth, it's awful. It's super salty, more salty than you would ever make your food, even if you love salt on your food. So then there's this little bitty piece up here. So now I'm going to make that a little bit bigger so we can see it. If this is that piece right there, blown up to be bigger, 3/4 of it is in ice. Either the glaciers or the polar ice caps. I'm going to make this darker because it's hard to see on the video. So this much of it, remember all your fractions people, if I divide this in fourths, this is 1, 2, 3/4, this part right here, and here's the 1/4 that's left over. So that's 25% for all you decimals and percents people. So then it says 22% of this fresh water is in, about 22% of fresh water is in groundwater. So most of this, 22 out of the 25, is in groundwater. I'm gonna go get another pen. This one's dying. All right, I'm back. So this is groundwater. We're going to learn what that means right now. And this up here is lakes, rivers, ponds, whatever. So the water that we see in the big rivers like the Mississippi River or in the Great Lakes, that teensy bit, which on this bigger picture is about as thick as that top line. Maybe something like that. Little skinny thing like that, I can't even draw it, would be the lakes and rivers. So a good part of the fresh water that we can actually use that isn't frozen into the ice and ice caps and glaciers is in groundwater. So let's find out more about groundwater. So groundwater is a vital source of fresh water, the book says. So starting right here, where my thumb is, it is important to understand how groundwater works. First, water gets into the ground when precipitation, that means rain and stuff like that, seeps into the rock below the surface of the ground. So it rains and the water soaks into the dirt and goes down into the rocks under the dirt. The ground is divided into several zones to help describe this process. The top part of the ground is called the zone of aeration. So if you look at the picture, that's the yellow part. The rock in this zone has many holes in it. This is how water flows through it. Below this is the zone of saturation. This level of rock contains many holes that are completely filled with water. When the zone of saturation meets the zone of aeration, this is called the water table. This is the surface of the groundwater. So that's the top of the completely soaked rock that's full of water. The water table, back to the book, the water table generally follows the contours of the surface. That means the shape of the surface of the ground, except it does not go up as high on the hills and does not go down as much in the valleys. So the water will be farther from the surface on a hilltop and closer to the surface in a valley. Groundwater generally flows downhill because of gravity and in the same direction as surface water, but it flows at a slower rate. Eventually, most groundwater finds its way to the surface. This happens in one of several ways. So it doesn't just stay under the ground, somehow it gets back out to the surface. Let's find out how. Groundwater can find an opening at a lower level, such as the side of a hill, in the side of a hill. When it does this, it forms a spring. Water often flows continually from a spring. Other times, groundwater flows in an underground river, which eventually flows into a lake, a surface stream, or into the ocean. We don't have springs around here very much. Back in the Midwest, where it rains a lot more, and we don't have quite as steep mountains back there as they do here, you'll have a place where the water that was under the ground at this level is going along, and then it comes up against a hill, and right here it just flows right out of the hill and onto the ground. It's like a little river that comes out of nowhere or out of the side of a hill. And the water is very, very clean. Sometimes you'll read in old books about people having a spring house, a place where they go get water. They build a little house just about as big as one person can fit in, where the cover's up where the spring comes out to keep it clean, and then they'll go in there with a bucket and get as much water as they need. It's really cool and fresh in there too. Let's keep reading. It is important to know the level of the water table, especially if you want to access the water in the ground. You want to get to it. Many farmers and some homeowners get the majority of their water from underground wells. This is what we have around here. Wells are drilled into the ground, and then the water is pumped out of the ground with an electric pump. Wells must be drilled below the water table in order for them to fill with water. Since the water table moves up and down with the amount of precipitation and with the seasons, the well must be drilled lower than the lowest level of the water table. So they can't just drill, if this is where the top of the water that's soaked into the rocks is, they can't just drill down to right here and just say, oh, we'll just suck it up like a straw. They have to go down past that so that they get into a place where there will always be water, even in the dry parts of the year. Let's keep reading. We're going to draw a picture of this on our paper that I'm going to show you in a minute. So just kind of hang with me. We'll look at the picture on this page, but we're going to do a little different picture. The flow of underground water, you see where we are? Right there. The flow of underground water is greatly dependent on the type of rock in the area. Some rocks do not allow water to flow through them at all. This kind of rock is called impermeable. Im means not, like, I can't think of a word, oh well. Most igneous and metamorphic rocks, as well as clay and shale, are impermeable. If there is a layer of impermeable rock near the surface, water will not flow into the ground. Instead, it will flow across the surface until it finds an area where it can sink into the ground, or it enters a river or a lake. In the mountains here, put your finger on the spot. In the mountains, we have the granite rock, the white rock with the black speckles. That is metamorphic rock. No, sorry, igneous rock, rock formed by fire. And water doesn't get through that. So there are places in the mountains where you can't drill a well. There's no way to get in there. There's no water that's under there. Reading back in the book again. Rocks that allow water to flow into it is called permeable rock. Permeable rock has many air holes that are connected to each other. This allows the water to flow through it. Gravel, sand, and many sedimentary rocks are all permeable surfaces that allow for the flow of water. So if you picture a bucket full of sand and you pour water into it, the water is just going to sink down in. It's going to go between all the little grains of sand. Or even gravel. Gravel's like giant grains of sand. Water can go in between little rocks of gravel very, very easily. Back to the book. Even though you may never see the water that is under the ground, you should remember that it is there. It may be a few feet below the surface or hundreds of feet below you, but it is there nevertheless. And this groundwater is what is used to supply much of the water needs for people around the world. So let's look at the picture. I'm going to bring this up close. So in the picture, we've got evaporation coming from the lake and from the trees and the plants up into the clouds, just like the water cycle. Forms clouds, it rains down. Some of it runs off on the surface. Right here it says runoff and goes right back down into here again. Here's the layer of permeable rock. So some of it sinks into the ground and goes down into this gray part that they're calling the water table. The water table is actually this edge between the yellow and the gray. And both these gray places are where the groundwater is. The brown is the impermeable rock. There's a couple layers of it. There's usually many different layers of places where water is under the ground. This water under here is coming from this mountain lake way up here. So this is kind of, the green part is the surface of the ground, and then they've sliced away the edge so you can see underground what's going on. So the rain comes down, goes some of it into the rivers, but a lot of it into the ground, and then either runs out into the ocean or is pumped back up by people to water their crops and to drink. So I'm going to make a third video where we're going to actually do the drawing of the way the water table works around here. It's not quite like this. So I'll see you back here in just a minute.